Evaluate the following limit. So we have the limit as x is approaching 0 from the right of x squared multiplied by the natural log of x. So we'll immediately try to evaluate this expression. So replacing all of the x's with 0 approaching from the right, we have 0 from the right squared multiplied by the natural log of 0 from the right. So this is going to be equal to 0 multiplied by negative infinity. And the reason that we know this is negative infinity is if we think about the graph of our natural logarithm. Here's your x-axis and the y-axis. And we know that the graph of a natural logarithm looks like such. So this is the inverse of the natural exponential. So here is x equals 0 at the origin. So we can see that as x is approaching 0 from the right-hand side, the y values are approaching negative infinity. So we look at this expression here and we think that's nonsense. This is undefined. It's an indeterminate form, which allows us to apply L'Hopital's. But as we prepare to apply L'Hopital's here, we have the limit as x is approaching 0 from the right of x squared multiplied by the natural log of x. We get stuck. And we're stuck because we remember L'Hopital's rule has to have a quotient as the argument. So L'Hopital's rule requires that we have the limit as x approaches x naught of some quotient f of x over g of x. So we're going to need to rewrite the argument of our limit so that it's in the form of a quotient before we can apply the rule. So we'll rewrite this limit. So this is equivalent to the limit as x approaches 0 from the right-hand side. And I'm going to leave the logarithm in the numerator here as the natural log of x. But x squared is also equivalent to x to the negative 2. Okay, and this is by our properties of exponents. So by the properties of exponents, we know that x squared is the same thing as 1 over x to the negative 2. And that's what we use here. So now we have the form of a quotient, and it is safe to apply L'Hopital's rule. So we take the derivative of the numerator and denominator separately. So the derivative of the natural log of x is 1 over x divided by the derivative of x raised to the negative 2 is minus 2 times x raised to the negative 3. And we're ready to, well, we need to simplify here before we can evaluate. So let's see, we have the limit as x is approaching 0 from the right of 1 divided by x all over negative 2 divided by x cubed. And we know that fractions in the denominator will flip. So we can multiply by the reciprocal. This is the limit as x is approaching 0 from the right of 1 by x multiplied by a minus x cubed all over 2. So we can cancel one x in the denominator with one of the x's in the numerator. So this is negative 1/2 multiplied by the limit as x approaches 0 from the right of x squared. And now it is safe to evaluate. So I have negative 1/2 multiplied by 0 approaching from the right squared, which simply goes to 0 when we think about the graph of the parabola, the quadratic function. And we find a beautiful final answer of 0.